Okay, let's proceed to the next subtopic, 6.2, root mean square. Singkatan dia adalah RMS. Okay, let's see what is RMS value. Okay, we know that in AC, the current is alternating quickly. So when it alternates quickly, okay, we have a sine graph, right? So kita ada sine graph. So apabila kita ada sine graph, so we have a few values of current. Maybe 5 seconds after it is connected to the power supply, the current reaches 1 ampere. Maybe 10 seconds, it is 2 ampere, and then they can reach maximum value. So we have a few value of current here. So because we have a few value of current, we cannot just pick any random number to represent the effective value. So compared to DC, we only have one constant value that flow throughout the circuit. But in AC, we don't have a constant value. So in order to find this effective value, kita panggil dia sebagai effective value. In order to find this effective value, we use a new variable, what we call as RMS. Okay, so we need a new variable to represent the value in AC. This is what we call as root mean square or RMS value. So there is a derivation of this formula actually, but you don't need to know that one. We just need to know what is the formula. Okay, we have two value here. We have the root mean square current. Okay, di mana the definition is it is the value of the steady DC which produces the same power in a resistor as the mean average power produced by the AC. So this is the formula. IRMS is equal to I naught, the peak value, divided by the square root of 2. And for RMS voltage, it is defined as the value of the steady direct voltage which, when applied across a resistor, produces the same power as the mean or average power produced by the alternating voltage across the same resistor. Okay, I know the definition is quite hard to understand, but like I explained briefly just now, that root mean square is just the value that we need as an effective value in AC. Okay, dia adalah effective value dalam AC. So this will be the formula for the VRMS. Sama jugalah macam IRMS, you just need to change that to voltage. Okay, so let's look at the example here. Okay, so we have example 5. An AC source of V is equal to 200 sine omega t is connected across a resistor 200 ohm. Calculate the peak current and the RMS current in the resistor. Okay, so we are given the expression here, where from this expression we know that 200 is the peak value of the voltage, and we are given the resistor 200 ohm. First, we need to find what is the peak current. Okay, we know that peak current, so this is the formula that we know just now. Okay, in order to find the peak current, we need to find the IRMS. Okay, but we are only given V naught and the value for resistance. So from here, you can actually guess that we can use the Ohm's law, di mana Ohm's law adalah sama dengan V is equal to IR. So if here is I naught, here will be V naught. If dekat sini adalah peak value, dekat sini pun akan jadi peak value untuk voltage. So we can get the value for the peak current. So here 200, I naught is what we want, times with the resistor. So I naught will be equal to 1 ampere. Now Question number 2. Calculate the IRMS in the resistor. So now that we have the peak current, we can use this formula to find the RMS current, which is equal to 0.07 ampere. Okay, senang je kan? Kita hanya gunakan this formula ataupun this formula. Okay, next one. Example 7. Okay, we are given a voltage against time graph here. Okay, the alternating potential difference shown above is connected across a resistor of 10 kilo ohm. Calculate the RMS current and the frequency. Okay, so this one, we want the same thing. We want IRMS, and then we want frequency. Okay, so from the graph here, what we can get is, we know that this value is the value for peak voltage, 200 volt, and we also know that one complete cycle will get you the value for the period. So period is 0.04 second. So from here, okay, keluarkan dahulu formula untuk IRMS sama dengan I0 divided by square root of 2. And then kita ada V0, so kita perlu cari I0 menggunakan formula Ohm's law. Times with resistor is 10 kilo ohm. So I0 will be equal to 0.02 ampere. And then we can get the value for RMS, 0.02 divided by the square root of 2, which is equal to 0.014 ampere. Okay, next one, we want to find frequency. Frequency is equal to 1 over period. And then period kita sudah dapat 0.04. So it will be equal to 25 Hz. Okay, senang je kan? So you just need to know how to use the formula.